Good morning. Welcome to this first Fronius webinar from Fronius UK. Today we're going to be talking about Fronius energy management applications, particularly for commercial installations, but also very relevant on domestic ones too. As well as looking at our smart meter and our energy management relay, we'll also talk about the Fronius Ohmpilot, which is a sophisticated energy management relay system for hot water systems. If you have any questions, feel free to write those in the chat bar on the right-hand side of the screen, and we'll answer them at the end of the presentation. My name is David Porter. I'm one of the technical advisors here at Fronius UK. So I look after the UK and the Irish markets, providing pre-installation design support, training, installation and commissioning support for PV installations. So if we have a quick look at the agenda for today, we'll start off by looking at self-consumption, what it is and why it's important now in PV systems. We'll then look at the Fronius smart meter and the various models of those that are already out in the market and being released later this year. We'll then look at the energy management relay and the Fronius Ohmpilot, which can be used for improving the amount of energy you use within your own building. So over the past few years, as many of you will know, the solar market has changed. We used to have very high feed-in tariffs, which meant that you got paid for the energy you generated, whether you used it yourself or whether it was fed back to the grid. Those have now been scrapped. However, the cost of electricity is still increasing, and the cost of PV system installation is getting lower and lower. So it still makes a lot of sense to install PV, but instead of before where you were just looking to generate as much as you possibly could, the key thing now is to consume as much of that energy as possible within your own building. There are various different ways that we use electricity. Obviously, just the general loads from things like lighting, heating systems, watching a TV. But you can also look at other systems that can be programmed and controlled during the day to improve your energy consumption. So for example, you can install an inverter with a battery system. That is something we'll discuss at a later date in future webinars. But today we're going to have a look at looking at switchable supplies. So things like hot water heating and other loads like EV chargers. For all of our solutions, we require the Fronius smart meter. As I just mentioned, there are a number of different units on the market. At the moment, the most common unit will be the Fronius Smart Meter UL, which is the black unit you see on the screen. These units come in two versions, the 240, which is for single-phase installations, and the 480, which is for three-phase commercial systems. Both units require CT detection, so whether it be one or three-phase, you'll need one or three CTs. Some of you may be familiar with the Fronius Smart Meter 50KA. This unit was used up until 2020 and also requires CT connections. These units came as a single option, and you just fit one, two, or three CTs depending on the type of installation you're connecting to. However, these have now been replaced with the Fronius Smart Meter UL. Another very important device which comes out very soon is the Fronius Smart Meter 100 amps. So this is a single phase meter designed specifically for the domestic market in the UK. It has a 100 amp supply rating and it has 25 millimeter terminals. So you can fit it directly into your main consumer board. Big advantage of this is it's a much cheaper unit to purchase, and also you don't need to have the additional CTs, so it's easier to fit into a small consumer unit. Once you've installed your Fronius smart meter, the simplest form of energy management is the energy management relay, and this is built into a full version inverter in every case. So within the inverter, you have your Datamanager card, And the Datamanager card has a series of I/O pins. These pins enable you to control external relays by supplying a 12-volt feed to that relay. So you have a very wide range of devices that can be controlled directly from the inverter. That can be electrical vehicle charging, it can be hot water immersion heaters, pool pumps quite often, and air conditioning units. But it's not limited to those options. Anything where you can switch on and switch off a load as a step load can be controlled by the energy management relay. And it's a very simple physical connection. We have the smart meter connecting into the Datamanager card on the Data Plus and Data Minus terminals. We then use the I/O controls up to 4 digital outputs, so we can control up to 4 different relays. We simply connect into the relay, supply that 12-volt signal, and then that closes the relay and supplies power to your load. It's a very, very simple solution, and it's, as I say, available with any inverter which has a Datamanager installed. Once you've made those physical connections, you can go into the Datamanager embedded browser, and you can set the controlling parameters. So typically, you'll be looking at a system where you want to switch on that load when you have surplus power. So that's when you have energy feeding back to the grid. So selecting that option, you can then set the thresholds. So when you switch on that device, for example, if you're feeding 1,000 watts back to the grid and you have a 1,000-watt load, set that switching on as your threshold. And then when you start to consume from the grid, so when there's other loads coming in within the building or the clouds come over and you start to draw energy from the grid, you can tell the units to switch off and open that relay so that no energy is used. You can then set the minimum and maximum durations during the day. And this is really useful if you have something like a pool pump, which only needs to be run for very short lengths of time. You can set that as a maximum, say, of 60 minutes. And also per signal, the minimum term can be set as just 1 or 2 minutes. So it's just a short blast of a heater, or it can be put on for a longer period if it's something that you need to have a good long period of usage from. Finally, you can set a night charge system. So a good example of this is if you have an EV charger and you want it to charge on an economy 7 low overnight tariff. You can simply state a period of time, so maybe 10 minutes, maybe 4 hours, and you can tell it to have that charging completed by a certain time of day. So for example, by 6 a.m., which may be the end of your lower overnight tariff. That means that you can get the required amount of charge into your EV charger and have the car ready to go for when you're heading off in the morning. So what's the impact of using an energy management relay? The key thing is that if you're using the feed-in rule, you're going to only be switching on that device when there is surplus energy. And that means where you see an increase in PV yield and export back to the grid, you'll have the device being switched on, which is this green load here. If you have a cloudy day and you have clouds coming over and you're not seeing that export back to the grid, then suddenly you're going to see the devices being switched off so that you're not going to be consuming from the grid. The Fronius Ohmpilot takes that one step further forward. So what we've seen so far is a single step on-off. So if you have a 3 kilowatt immersion heater, you're going to really need to have 3 kilowatts of export before it makes sense, because otherwise switching on a 3 kilowatt immersion when you have less than 3 kilowatts of export means you're going to be demanding electricity from the grid. The Ohmpilot's benefit is it's a stepless immersion or hot water supply. So it means that if you only have 500 watts of excess, only 500 watts of load is put through that immersion heater. So let's have a look at the benefits. As I say, it's a stepless single phase option up to 3 kilowatts. So connected to the inverter, you're able to modulate that output and that supply to the immersion up to 3 kilowatts. But if you have a 3-phase installation and a 3-phase immersion, you can actually install up to 9 kilowatts of immersion heating with this one device, which makes it a very cost-effective solution on commercial installations. It works with export limitation. So if you've already got a 0 export limit on your site, this will work as well with that device. So it means that you can get more generation out of your inverter. So whereas an inverter would normally be sat at the export limit, this will enable you to put up to another 3 kilowatts output from your inverter into a hot water system. It can be used alongside the energy management relay that we saw before. This is particularly useful for single phase installations. So you can have your 3 kilowatt Ohmpilot and then another device as well. So you can make those work in tandem. And that means that you, again, can get some level of stepless control, even with bigger than 3 kilowatt loads. And you can retrofit this to existing installations. It works obviously with all Fronius inverters, but it can also be installed with other manufacturers' equipment, provided you also install a Datamanager box and a smart meter. It can be connected to a PT1000 temperature sensor, and this enables you to have more control over the device. It means you can set target temperatures. It means that you can switch off the device once you hit the required temperature, and it means that different times of day you can set the different requirements. It also means that we have visualization in our SolarWeb platform, which it means that we can actually track the performance and we can see how much hot water we have being produced. The Ohmpilot as well will allow you to see the amount of energy diverted. We can see the extra performance and the extra savings to the end customer. That means you can improve the self-consumption. It means that we can see how many extra kilowatt hours throughout the course of the year have been used within the building as opposed to being exported back to the grid. The device can also be used to control other heating devices. So you can have, for example, hot water being heated by a gas boiler and by the Ohmpilot, and the relay control within the device can then switch on the gas boiler as and when required to assist if there isn't enough hot water being generated by the solar. We have a boost button, which means that you can press the button simply to increase the heat of the water to heat up the water for a period of up to 4 hours. And again, that's a very simple solution if you want to get some hot water quickly. And it's compatible with other technologies. So as I mentioned, we can use this with other inverters, but we can use it, for example, with a wind turbine, provided you have that smart meter and Datamanager installed. Anything where you're exporting from a site to the grid can potentially benefit from the Ohmpilot. And as I say, the Ohmpilot works not just with hot water, but with any resistive loads. So you can use it, for example, with electric floor or wall heating or infrared panels. But the most common usage of the Fronius Ohmpilot is in heating rods, so immersion rods. And if you use a 3-phase immersion, it's important that you get one with a neutral connection. That's required for the device to work. So we have a quick look at how the hot water preparation takes place and the logic behind it. If you have a domestic installation with a 1500 watts generation from the inverter, you may be seeing about 1 kilowatt of that being used within the building. So for your lighting, your washing machine, whatever it may be. And you're going to have about 500 watts going back to the grid, and that's going to be read by the smart meter. So as soon as the smart meter sees that export, it's talking with the inverter, and then the inverter is talking with the Ohmpilot. And as a result, that 500 watts of surplus is diverted to the Ohmpilot. So we see nothing going back to the grid now, and instead we see that 500 watts of additional energy being used within the building to heat the hot water. But then as the sun comes out, the sky's clear, you may see an increase in generation from your inverter. So we might now be up to 5 kilowatts. And that means that the Ohmpilot can increase its output up to the maximum for a single phase, which is 3,000 watts. We still get that 1,000 watts load within the building. So it means there is now some surplus that's going back to the grid. So on a single phase like this, you could then be looking at potentially installing a battery if you've still got a lot of exports back to the grid, or setting up an energy management relay as well from the inverter to boost the generation even further, to boost the load even further. So let's have a look what's actually inside the box. So the picture you see here is with the front cover off. We have a large heatsink on the right-hand side of the inverter. We then have at the front the communications board, and behind that we will then also see the connection area for the electrical connections. If we zoom in on that, you can see on the communications board we have various connection options which look more which are clearer if we have a look at the schematic. So if we look at it as a schematic, we can see we have 3 status LEDs. We have the power, the Wi-Fi status, and an error code there, 1, 2, and 3. Number 4 is the boost button that we mentioned before for boosting the energy that's being used to heat hot water. It's also used to open the Wi-Fi access point for setting up the device. Number 5 is a LAN port, so that's an RJ45 connection, so you can connect straight to your router. Number 6 is an RS485 connection. So you have 3 different communication options here. You've got the Wi-Fi, which is shown by the blue flashing light, number 2. You have the Wi-Fi, you have the LAN connection, number 5. And if you don't have an easy route back to your router, you can connect to the Datamanager or to the smart meter through the RS485. You then also have the PT1000. So that's the temperature sensor, which is simply connected onto terminals number 7. Below that, on the backboard, we have the incoming supply terminals from your distribution board. So this is 1, 2, 3 phase system that feeds in directly from your circuit breaker. Number 9 and number 10 are the second and third phase connections. So if you're having a 2 or 3 phase supply, these are the outputs to the immersions. Number 11 is the relay output. So this is if you're connecting to an external device like a gas boiler, and it means that you can switch on, switch off that gas boiler from this relay. And then finally, number 12, this is the stepless single phase heater, so up to 3 kilowatts. So if you have a single phase installation, you're connecting in on L1 and you're connecting out on the out port on block number 12. With a 3-phase solution, you're doing the same thing, but you'll also be using blocks 9 and 10 as well. In the connection area, as I just mentioned, you have the RJ45, you have the Wi-Fi connection, and we have the Modbus option as well. If you go with the Modbus option, you do need to set the dip switches on the board. So we need to have a termination resistor, which needs to be switched on, and then we need to give the device a Modbus ID as well. Some people ask, what's the best way to connect? Well, the easiest way is to use Wi-Fi, obviously. You have a WPS option there, so 3 presses of the boost button and then press of the router WPS button means that they should be able to automatically detect. So most of the time, that is the best option. However, if you've got a long distance or there's a poor signal to your Wi-Fi, you may choose to use the Wi-Fi, the LAN option instead. Alternatively, if you're retrofitting to an existing installation and you have the inverter a long way from the router, but very close to the Ohmpilot, you may just want to use that local connection with the RS485. So you've got a number of different options there to get the communications to work between the various devices. So once you've undertaken the wiring of the device, you then can use the embedded browser in order to program the device. The view you see on the screen here, this is the general overview for the system. You'll see the status of the device, which should be okay. If you have a temperature sensor installed, you'll be able to see the temperature of your hot water or of your ambient temperature. And then you'll be able to see if the device is currently being used. So this screenshot here, as you see, 0 watts, the system is in standby, waiting for any excess energy to be generated by the inverter. If you have additional heaters or second or third phases, they will also be listed below. If you click on the General tab, you'll then be able to see some more details. So most of the time, you'll be using automatic mode, which means that the device simply detects the load that it can put through the immersion. It means that it will automatically set up to divert all excess energy through into the Ohmpilot. But you do also have the option of manual connection. And that means that you can set up a maximum load for the system, and you can also set temperature sensors. So you can control the actual temperature of the water, and you can set a time of day requirements, temperature requirements for the device. So you can make sure that you've got hot water first thing in the morning. You can make sure that when you get home from work, that the water's back up to temperature where you want it. You can set the maximum temperature, of course, and also we have the option of Legionella prevention. And this is a very useful option. If during the winter you have very poor weather, there's no surplus energy available, you can still set this maybe once a week to switch on, heats the water through the cylinder, kill any Legionella bacteria that may be present. So as I just mentioned, if you have the temperature sensor, you can adapt the day curve. You can set the temperature requirements at different times of day. You can also include a second heater. So this could be an external unit, just like with the energy management relay. So you can switch on that external device. You can also use it to switch on something like an air source heat pump or a gas central heating system. So this shows that you've got a number of different options. You can really get into a lot of detail with the Ohmpilot. It's a lot more than just switching on and switching off a relay. If we have a look at the difference between a system without any load management and one with the various devices, you'll see that you can really increase the use on site. So this is actually modeling our system at Fronius UK. And you can see on a good day, we'll have a fair amount of green export back to the grid. If we then put energy management relay in, just on a single phase option, we'll see a fairly good increase in usage on site. If we have an energy management relay and an Ohmpilot, we can start using more energy early in the day when we've got enough to use in the Ohmpilot, but where it's not quite enough to reach the threshold of the energy management relay. We still have a little bit of feed-in back to the grid in this instance. So for us, the best option is to have a 3-phase Ohmpilot. If we have a three-phase Ohmpilot, we're now able to use all of the energy that we produce during the day. There is a tiny amount of feed-in in the early afternoon, but the vast majority of that energy is now used all day long. And because we have that stepless load option with the Ohmpilot, it means even early in the day when there may be just a few hundred watts available, that's all going back into the hot water tank. So there's a lot of data being produced here, and it's good that within SolarWeb we can actually see what's happening with our systems. Before we even install an Ohmpilot, it's worth actually seeing if the customer will benefit. So we have a simulation tool that's built in. If a customer already has a PV system with a smart meter, they can run this simulation on the SolarWeb website. What we do is we click on the type of fuel that we're using, the size of cylinder, click simulate, and then what the system will do is calculate how much energy can be diverted to that hot water over the course of the year, and it can recommend the improvement in performance of the system. It can suggest the benefits of having an Ohmpilot installed. As you see here, the yellow sections in April, May, June, August and September show that the system will be mostly heated from the solar. Over the winter months, yep, of course, in the UK, we're not going to see great deals of sunshine in the deepest, darkest winter. So then we're still using a fair bit of energy from the grid and from the gas system in this instance. But you can at least get a really good idea here of the potential benefit of installing an Ohmpilot. And it's a good sales tool for you to go back to your customer maybe a year after the installation and suggest an upgrade to their system. It gives you some good detailed numbers that you can go back to. So once you've shown that there's a benefit from the simulation, you can install the unit, and we'll actually see some new data appear in SolarWeb. So some of you may be familiar with the SolarWeb dashboard. We have the current power view here, and this shows energy being generated by the solar coming into the building. We then see energy coming in or going out of the building, and we see the consumption on site. If you click on this, it will expand, and you'll be able to see the current consumption. So for example, on this installation, we have 8 kilowatts of consumption on site, and the Ohmpilot is currently supplying 3.1 kilowatts. So that's all coming from the PV system, and so we only have 1.4 kilowatts going back to the grid. You can also then see the energy balance for today. And this is again a very interesting view. You'll see in red where you're feeding back, where you're receiving energy from the grid, and you'll see in green where it's feeding to the grid, feeding into the grid. And if you click on that, you can then see a breakdown of your energy over the course of the day. And if you have the Ohmpilot with the temperature sensor installed, you can also see the temperature of that water in the tank. So you'll see overnight it slightly reduces, cooling down, but then as soon as the Ohmpilot's coming in and we have a significant amount of additional heating, the water temperature increases. It then reaches 60, which was set as the maximum temperature of the device, and the Ohmpilot is able to switch off then. Once it switches off, obviously we're seeing some feed into the grid, and that will continue on. But if you then required some hot water, the temperature drops in the cylinder, the Ohmpilot will be able to switch back on and take more of that energy again. Over the course of the year, you'll actually be able to assess what you've done each month with the device. And obviously you'd expect to see the best performance of this over the summer months when you've got the most sunlight. That means potentially you could be switching off your fossil fuel heating system for a number of months. If you're not using it for heating and you're not needing to use it for hot water, there are significant benefits from having the Ohmpilot. But we still see a fair amount of additional consumption even in winter months here. So just to summarize what we've seen today, The focus is very much now on self-consumption within a PV system. The lack of a feed-in tariff means that all of the savings now come from reducing your requirements from your utility providers. The smart meter is a really important part of this, whether alone just for monitoring and analysing your usage, or if it's being used with the energy management relay, a battery, or the Ohmpilot. It identifies savings, it helps you to monitor what's happening, and then it also controls those additional units. The energy management relay is a basic stepped control system which is available in any inverter with a Datamanager, with up to 4 loads available, and it's stepped, so it means you don't have that fine adjustment, but it can be controlled for various different devices, whether that be a resistive load, whether it be a motor or another device. And that, remember, is free within every Fronius Datamanager or Fronius full version inverter. And then finally, we've looked at the Fronius Ohmpilot, which provides that stepless control up to 9 kilowatts on a 3-phase installation or 3-phase single installation. That can be used in conjunction with all the other devices we've seen today. It means that you can build up complex systems, or you can keep it very simple using it in automatic mode, just plug and play. In the UK, where most domestic customers are single phase, we suggest that this is better suited to commercial installations. The fact that it's a 3-phase system is a real benefit. It works out much more cost effectively than 3 individual single phase units. And that means that key customers that we would suggest focusing on are people like schools, sports clubs, maybe surgeries, meeting halls, places where there is a requirement for hot water, maybe sites where they use that hot water in the evening as well at the end of the day. Any system where you've already installed that smart meter and a Fronius inverter mean that you can actually assess that usage. But it's really good opportunity now to go back to your existing customers, have a look through the data and see if there's any way that you can really improve their usage. And the Ohmpilot is a really ideal option for this. So thank you very much for your time today. We will be running a number of these webinars in the coming weeks, focusing on different Fronius technologies and services available. I'd just like to remind you that we have the Fronius Solar SOS tool if you need any support, tech support, and you'll also find details of all of our trainings online at fronius.com.
Hi everyone, thank you for attending our webinar. For those of you who don't know, my name's Natalie. I work on the marketing team at Fronius UK. I've got a couple of questions in the question box for you, David. If anyone else has any questions, please feel free to submit them in the question box, and then I'll get those asked to David for you. So David, first one we've got is, can I add an Ohmpilot to an existing PV system?
So yes, that's one of the key advantages with the Ohmpilot. You can retrofit this to an existing Fronius system. So if you've already got the Datamanager and the smart meter installed, all you'll need to add is the Ohmpilot. If it's another manufacturer's or it's a Fronius without the monitoring, you'll also need to just install the Datamanager and the smart meter as well.
David, and the next one we've got is, what would be the maximum wireless range between the inverter and the Ohmpilot?
So the Ohmpilot and the inverter don't talk to each other directly. They will talk through the router if you're using Wi-Fi. So the key thing is to check your Wi-Fi range from your router to the location of the inverter, and also to check the Wi-Fi range from the router to the Ohmpilot. If you're finding it's quite a weak signal, you can always put a Wi-Fi repeater into the system. That will obviously boost the range. Alternatively, you might find it easier just to put the hardwire connection in, or even power line communications. So you've got a number of different options there.
Well, thank you. And then we've got another question here of, could the Ohmpilot be used to divert power to other forms of consumer, such as infrared heating?
So yes, as long as it's a resistive load, so infrared heating is a good example, it can be used, it can be controlled with the Ohmpilot. The key thing is to make sure that there's nothing like pumps or any other capacitive, inductive loads in the system, just purely resistive loads. But yes, infrared heating is a good example, underfloor heating as well. Yeah, those are absolutely fine for use with the Ohmpilot.
Perfect, thank you. So that's all the questions that we've had submitted. What we will do, you can obviously drop us an email if you have any more. The best email is pv-support-uk@fronius.com. That goes direct to our team of tech support guys, and they will be able to answer any questions. Within the box, you should be able to see a few handouts as well. So we've got the data sheets for the Ohmpilot, the Datamanager, and the smart meter. And we've also got the little B2C brochure for the Ohmpilot as well for any of the installers that are talking to their customers about it. So you can download those, and if you also need them, they're all on our website. Or like I say, if you need it, just email one of the team and we'll be able to send those over to you. So thanks very much, everyone. We'll be running more soon, so keep an eye on our social medias and our website for when the new dates come in. Thanks, bye.